Okay, so yesterday we worked on simplifying radicals, and we multiplied them, and we divided them, rationalized them, that kind of stuff. Today we're going to add and subtract and multiply radicals, and we're also going to rationalize the denominator on radicals. We've already done some of that. We're going to do more rationalization in a little more detail today than what we've done in the past. Like radicals, have the same index and the same radicand. So the square root of 2 is like the square root of 2 is like the square root of 2. But the square root of 2 and square root of 3 are not like radicals, because although they're both square roots, 2 and 3 are not the same radicand. And when you have, let's say, the cube root of 2 and the square root of 2, they are not like radicals, because even though the radicand's the same, the index is not. They need to look exactly alike. And when you're combining them, you combine them up just like you would a variable. Okay, 3 root 2 plus 4 root 2 would be the same thing as 3x plus 4x. You treat it exactly the same. Okay, when you're adding and subtracting, we're going to do a lot of that. Rationalizing the denominator, removing radical terms from the denominator by multiplying them by the conjugate. We'll be doing that today. We did that some before when we got rid of our i's and our denominators. Back when we were working with that, we're going to use pretty much the same process. Same concept, I should say. Okay. And we're only dealing with the square roots in those for the most part. You can't do them with other ones, but ooh, it's not easy. Okay. So here we go. So the first one, combining up like terms, add or subtract, radical expressions, and simplify. So once again, they need to be like terms. If I had instead of 3 root 5, I had 3x. Instead of 2 root 5, I had 2x. Instead of 7 root 5, I had 7x. Could you do that? Yeah, it's really easy, isn't it? You've done that lots of times. 3 minus 2 is 1. 1 plus 7 is 8. You have 8x. It works exactly the same for radicals. I have 3 root 5 minus 2 root 5 plus 7 root 5. I have 3 apples. I take away 1 apple, and I add 7 apples. How many apples do I have? Doesn't matter whether I'm talking about apples or x's or root 2's. It's treated the same. It's like terms. So I have 3 root 5s minus 2 root 5s. That's 1 root 5. Plus 7 root 5 means that I have 8 root 5. Okay, they have to be like terms. So they're like terms, like radicals. I can add them together. So I look at the next one. 6 4th root of 2 minus 2 root 7 plus 1 4 root 2. Remember, we're lazy. We don't put a 1 in front if we have 1 of something. Same concept. If this was 6x minus 2y plus x, you could do that. Same idea. I combine up the like ones. My like radicals are these two here. So I have 6 4 root 2's and 1 4 root 2's. That means I have 7 fourth root of 2. Okay. And then what else do I have left? I have that. There are no other root 7's. So it's minus 2 root 7. Okay. The next one is tricky. Okay. None of those are currently like radicals. As it stands, I cannot combine any of them together. That would be too easy. So what do? We need to see if we can simplify the radicals first. And if we can simplify the radicals, then we combine them together. So for example, the square root of 12 is 2 root 3. Square root of 4 times square root of 3, 2 root 3. The square root of 75, well, that's the square root of 25 times the square root of 3. So that's 5 root 3 minus 1 root 3. So 2 root 3 plus 5 root 3, that's 7 root 3 minus 1 root 3. That gives me 6 root 3s. Okay. But I have to try to simplify them first if I can. If I can't simplify them, they're done. Okay, if I can't simplify them out, we can go from there. I look at the next one, 2 fourth root 5, 6 root 5. I can't simplify. They're not like radicals any chance by any way, anyhow. Because I have a fourth root of 5, I can't do anything that. Square root of 5, I can't do anything that. This one is actually finished as it stands. Because even though they're both roots of 5, one's a fourth root, one's a square root, they're not like radicals. And this is one where it gets fun. Okay. As this one stands, once again, I cannot simplify. However, I need to try. It's a little more difficult than square roots because I have cube roots, but you have a hint. You have a hint. You have the cube root of 2. You cannot do anything at all to the cube root of 2. These ones here can probably simplify down into something cube root 2. So what 2 times what gives me 54? 27. So that's the cube root of 27 times the cube root of 2. I'm using what's already in the problem as a hint on how to simplify. Okay? 27 is a perfect cube. 27 is the cube root of 27 is 3. So I have 5 cube root 2 plus 3 cube root 2. And I use what's already there as a hint for my simplification. This also works with square roots. If you have one that's already simplified, use that as a hint on what's trying to simplify the other ones. It's no guarantee that's what it'll be, but at least that's a starting place. So I do the same thing with 16. So 16, 2 times what gives me 16? 8. So that's the cube root of 8 times the cube root of 2. That's what the cube root of 16 is. What's the cube root of 8? 2. So the cube root of 16 is 2 cube root 2. Now they're all cube roots of 2. Now I can combine them together. 5 plus 3 is 8. 8 minus 2 gives me 6 cube root 2 for my final answer. And the next one, that's actually probably an easy one. Root x, root x. They're all like radicals. They're all square roots of x. I don't know what x is, but it's the same number for x whenever it is. So these are all like radicals, so this is easy. 2 plus 1 is 3. 3 minus 6, negative 3, root x. And remember, they have to be like radicals to combine by addition or subtraction. If they're not like radicals, see if you can make them like radicals. You might not be able to, but you might. Your turn, do these. Okay, let's go ahead and do these. First one's easy. They're already all like radicals. They're all the square root of 11. Can't do anything. So 3 minus 8 is negative 5. Negative 5 plus 1, negative 4 root 11. The next one, they're not like radicals. I cannot simplify the square root of 3. I cannot simplify the square root of 6. I can, however, simplify the square root of 12. Certain radicals, you should start picking up on what they are in simplified. We've done enough of them. There are certain ones you should start to get. Square root of 12. We've done the square root of 12 an awful lot in here. It's one of those ones you're going to see an awful lot. It's an extremely common one to be asked to simplify. So you should know that the square root of 12 is 2 root 3. That should start be getting into your subconscious at this point. We've done it often enough. Okay? So I have 5 of those, which means I multiply 5 times 2. So I get 10 root 3. That's what my first term is. I can't simplify the other 2, so I combine up the ones with the same. 10 root 3 minus 7 root 3. So I have 3 root 3 plus 2 root 6, and that's it. I can't do anything else. On this one here, cube root 2, can't do anything to those. Cube root 16, I can. And we did this on the previous previous example. And the cube root of 16 was 2 cube root 2. That's how it simplifies to. We did that on the previous page. Okay. Now they're all cube roots 2. Add them all together. 2 plus 9 is 11. 11 minus 5, 6 cube root 2. Next one, same idea. Cube root 2 can't do anything to that. Square root 2 can't do anything to that. Cube root 2, cube root 16. Listen, we just did the cube root of 16. This is 2 cube root 2. I have 2 of them, so that means this whole thing is 4 cube root 2. And then the square root of 18. Square root of 18 is another one that's fairly simple you should pick up on. It's not nearly as common as the square root of 12, but the square root of 18 is square root of 9, square root of 2, so that's minus 3 root 2. And you should look at the rest of the problem for hints as simplifying. I've got a square root of 18, I've got a square root of 2. I might be able to make them both root 2s. Might not, but that's probably what's going to happen. Now I combine up my like terms. 4 cube root 2, another 4 cube root 2. That means I have 8 cube roots of 2. And then I have minus 6 root 2, minus 3 root 2. That's minus 9 roots of 2. Okay. Look at the rest of the problem. If they're not all simplified, if they're not already all like radicals, look at the most simplified ones for clues of how to simplify the ones that are already there. Because usually they will end up being like radicals. Sometimes they're not. Sometimes even after simplifying, you still can't combine them together. But more than likely you will, because that's the way they write the problems. Okay? Try to pick numbers where things work out the way we want them to. Okay, multiplying the radical expressions and then simplifying. We kind of sort of did a little bit of this on Tuesday. This is actually a simpler version of what we did on Tuesday. Okay, the first one is straightforward. Okay. Anything that's outside stays outside. Stuff that's inside stays inside. They do not have to be like radicals for multiplying. They do, however, have to have the same index. Okay. So I have 3 times negative 5, that's negative 15. Root 2 times root 7, that's root 14. And then I think, okay, can I simplify the square root of 14? I can't, so I'm done. If I can't simplify my root after multiplying, I simplify my root after multiplying. I can't in this case, I'm done. The next one, same concept. Negative 2 times 8 is negative 16. Root 3 times root 2 is root 6. And I can't simplify that. I'm done. Okay, square root of 6, there's no perfect square that goes into it. I have on the next one cube roots. I can multiply them together because they are cube roots. So the radical portions can be simplified because they're both cube roots. If I had a cube root and a square root, I would not be able to multiply them. Okay. So once again, I do the numbers in front. 5 times negative 6 is negative 30. Cube root 2 times 5 is 10. How many? What am I used to? Yeah. Just grab an empty seat for now. We'll get you out here. Okay. So once again, when you're multiplying, what's the radicand, the part underneath, doesn't need the same. You just multiply that, but the roots do need to be the same. Or right here. No, you're fine. I believe you. Okay. So, next one. Not exactly the same. It's not just plain multiplication, but this is you're foiling two binomials. This is this. You work this the same as x plus 2 times x, minus 3, something like that. You're multiplying two binomials, so you FOIL it out. 2 times 2 is 4. 2 times minus root 3 minus 2 root 3. Root 3 times 2, 2 root 3. And then root 3 times negative root 3 is negative 3. When you multiply a square root times itself, square root of 3 times square root of 3 is 3. Square root of 2 times square root of 2 is 2. Okay, start to understand that fact. It makes your life easier if you, the square root of something times itself is just the radicand underneath. And now I combine up any like terms. I have 4 minus 3, that's 1. And the negative 2 root 3 and the positive 2 root 3 cancel, so I get 1. Works out sweet. Okay. Next one, same idea. Only I don't have like radicals. That's actually going to make my answer probably a little more complicated, but I just FOIL it out. First, outside, inside, last. Okay. 4 times 1 is 4. 4 times negative root 5, negative 4 root 5. Negative root 2 times 1 is negative root 2. Negative root 2 times negative 5 is positive root 10. Do I have any like radicals? No. Can I simplify any of them? No. Square root of 10, there's no perfect square goes into it. 2 and 5 are primes. It's the way they are. It's done. That's my answer. I can't do anything to it. I'm finished. Okay. 6 minus the square root of 2. Okay, 2 things. You have to remember, actually I said one key thing. Remember, what does it mean to square it? That means I have 6 minus root 2 times 6 minus root 2. You do not square 6 and do not square the square root of 2. You cannot distribute exponents across subtraction or addition. Okay, it's 6 minus root 2 times 6 minus root 2, and you FOIL that out. 6 times 6 is 36. 6 times minus root 2 is negative 6 root 2. That's this one here, and then this one here, I get the same thing, minus 6 root 2. And then negative root 2 times negative root 2 is plus 2. Root 2 times root 2 is 2. And the negative times the negative is a positive. Combine up like terms. 36 plus 2 is 38. And then 6 root 2, 6 root 2, negative 12 root 2. You've done this before, only with variables. Same process, but numerically a little bit different. But it's still the same thing. When you have a binomial times a binomial, it doesn't matter what those objects are. You just FOIL it out. And then if you have any answers you can combine up, you can combine up anything you can get. Sometimes you can, sometimes you can't. Okay. This one's actually not too bad. So, first 2 terms. 3 root 2 times negative 2 root 2. Square root of 2 times square root of 2. I'm actually going to do this one slightly different so you can see how it works. 3 times negative 2, negative 6. Square root of 4. Because what is the square root of 2 times the square root of 2? It's 4. Negative 3 root 2 times negative 3 root 5. Minus 9. root 10. Root 5 times negative root 2 is negative 2 root 10. And then root 5 times negative 3 root 5 is negative 3 root 25. I know I did this a little differently. The reason is I have whole numbers and roots mixed together, and I want to make sure that everybody can kind of keep track of where I get my final answers from. What is the square root of 4? 2. What's 2 times 6? What's 2 times 6? Come on, it's not that one's not that hard. It's 12. Negative 12 minus 9 root 10 minus 2 root 10. And then what's the square root of 25?
5.
What's 3 times 5?
15.
15 minus 15. Make that 10 a little better. I've simplified all my radicals, combined up like terms. Negative 12, negative 15 is negative 27. Negative 9, negative 2, negative 11, root 10. It's not terribly difficult. It's just, you got to be careful. Okay, watch for errors. It's easy to find errors in here. Okay. Your turn, do those. Okay, so let's do this. First one, negative 4 times 2 is negative 8. And then root 5 times root 10 is root 50. I can simplify the square root of 50. 50 is 25 times 2. So this is 5 root 2. So I have negative 8 times 5. I get negative 40 root 2. Next one, negative 7 times negative 3, I get 21. 3 times 18 is 54. And the square root of 54 is simplifiable. 54 is 9 times 6. Square root of 9 is 3. 3 times 21, 63. Root 6. Now, you could have, and I don't know if anybody did this or not, you can simplify the square root of 18 first. The square root of 18 is 3 root 2, so this would become negative 9 root 2. Negative 9 root 2 times negative 7 root 3 gives you 63 root 6 as well. So you could have simplified first if you wanted to, and then multiply it, and guess what? You get the same answer. It doesn't matter. Okay? It doesn't matter. As long as the numbers aren't too big, I generally go ahead and multiply first and then simplify my radical. It depends upon how big the numbers are. If the numbers are really big and I can simplify them first, I simplify them first, and then maybe simplify them again later. All depends upon how large the numbers are. It's easier to work with smaller numbers than big numbers. Okay? Even I do that. Next one, FOIL it out. 5 times 2, 10. 5 times root 3. 5 root 3. Negative root 7 times 2 is negative 2 root 7. Negative root 7 times root 3 is plus root 21. And that one's done. There are no like terms, and the square root of 21 is not simplifiable. There's actually a shortcut on this one. Yes.
Wait, wouldn't it be negative root 21 because the 7?
You're right. It is negative root 21. My bad. My bad. There you go. Pointing out my mistakes. Making the teacher look foolish. No, that's okay. Yes, please say something before I get too far along. I do make mistakes. I am really careful on answer keys, though, to not make mistakes. And I really try hard not to do that. There is actually a shortcut on the next one. If you look at the next one, and you can think about it being something like x plus 2, x minus 2. They're exactly the same except for plus and minus. It's a shortcut for that. Square the first term minus square the second term. That works here as well. If they're exactly the same except for plus and minus, You have a shortcut. Square the first term, square the second term. Take 2, square it, you get 4. Minus the square root of 5 squared, which is 5. 4 minus 5, you get -1. Now, if you FOIL it up and combine up like terms, you'll still get -1. Okay? It's just one of those things that you did that in Algebra 1. We did that earlier this year. I want you to look for those shortcuts, and they'll be a little more important on the next section, next page of notes. Okay, this one here, remember 7 minus root 3 is 7 minus root 3 times 7 minus root 3. This is not the same as that one because these are both the same sign. Remember, that's plus and minus. These are both minus in between. So you have to FOIL it out. 7 times 7 is 49. 7 times negative root 3, negative 7 root 3. Negative root 3 times 7, negative 7 root 3. Negative root 3 times negative root 3 is plus 3. Combine up your like terms. 49 plus 3 is 52. Negative 7 root 3 plus negative 7 root 3 is negative 14 root 3. Last one, same thing, several steps involved. 4 root 2 times minus root 2 is negative 4 root 4. 4 root 2 times 3 root 3 is 12 root 6. Negative root 3 times negative root 3 is plus root 6. Negative root 3 times negative 3 root times 3 root 3 is negative 3 root 9. And the reason I did this is because I have numbers in front and numbers underneath both. It's easy to get mixed up otherwise. Take that extra step, makes it easier to keep track of what you're doing. Root 4 is 2, so this is negative 8. Square root of 9 is 3. This is minus 9. And then combine up like terms. Negative 8 and negative 9, negative 17. 12 root 6 plus 1 root 6 is 13 root 6. Now, if when you multiplied 4 root 2 times negative root 2, you went straight to negative 8, I'm good with that. Okay, I'm okay with that. You don't have to have that extra step in there. I just, sometimes students get confused when I skip that step and combine them up in one. Okay? But if you did that, fine, great. It means you understand what you're doing. Questions on these? Okay, now comes the fun part. Used air quotes. Okay. Fun for me, not so much for you guys. Rationalizing the denominator and simplify. Rationalizing the denominator means no radicals in your denominator. Notice these are all square roots. That makes it much, much easier. It's very hard to rationalize denominators that are not square roots. We don't do that to you in here. Okay. First one's easy. And all of them I do actually the same step. I multiply times 1. Every one of these I'm going to multiply times 1. I multiply times 1 because I don't want to change the value. I just want to change how it looks. So the first one is the easy one. I multiply by what my denominator is, root 7 over root 7. So root 7 over root 7 is 1. It just doesn't look like it, but it is 1. The idea is to get rid of the radical in the denominator. Multiply my numerators. Root 2 times root 7 is root 14. Root 7 times root 7 is 7. That's my answer. If I can simplify, simplify. If you can't, don't. Okay? And this one's easy. Why? Because it only has the square root by itself and nothing else there in the denominator. The next ones are a little more complicated. But we did this before. When we did this with I. Because I was the square root of negative 1, we had to get rid of our i's and our denominators. We did this before. And you multiply by the conjugate. The conjugate is your denominator with the sign between them changed. So on this first one here, I multiply by 4 minus the root 3 over 4 minus root 3. Only the number between them changing. Now the numerator is easy. I just distribute 2. 2 times both of those. 2 times 4 is 8. 2 times root 3. Sorry, and that should be a minus. Minus 2 root 3. My denominator is a little more complicated, but we just did this on the previous page. If they are conjugates, which means they're exactly the same except for plus and minus, shortcut, square the first term. Take 4 and square it, you get 16. Minus the square of the second term. Square root of 3 squared is 3. Look, no more radicals in my denominator. That's what I want. I don't care about my numerator. I just don't want radicals in my denominator. If they happen to disappear in the numerator, whoo, but that doesn't happen very often. So, take this one more step, combine my denominator. I get 8 minus 2 root 3 over 13. Piece of cake. Next one, same idea. Multiply by the denominator with the sign between the two numbers changed. So I multiply by root 3 plus root 5 over root 3 plus root 5. My denominator on this is simple. Distribute. 2 root 7 times root 3. 2 root 21. It's underneath the radical, it gets multiplied and stays there. 2 root 7 times root 5. 2 root 35. Blanked on 7 times 3 for 5 for a minute. My denominator, once again, fairly simple. Square the first term. Take square root of 3 and square it. You get 3. Minus the second one squared. Square root of 5 squared is 5. 3 minus 5. No more radical in my denominator. Simplify your denominator. 2 root 21 plus 2 root 35 over negative 2. I can simplify this one. Everything, and it has to be everything, is divisible by 2. 2 root 21, 2 root 35, minus 2 in my denominator. Actually, technically divide them all by negative 2. Because I want to make this a 1 in my denominator to get rid of my denominator altogether. Because I have the 2 out front, and the 2 out front, and the 2 down here. They're all divisible by 2. Divide everything by negative 2. You get negative root 21 minus root 35. And that's your final answer. This one, my denominator happens to disappear. Don't always count on that. It works on this one. Okay, next one. My denominator is what determines what I multiply by. I don't care what's in the numerator. For my multiplication purposes, for deciding what to do. So I multiply by 4 minus root 3. 4 minus root 3, 4 minus root 3. My numerator in this one is a little more complicated to multiply by. But we just got done doing that on the previous sections. Boil it out. 6 times 4 is 24. 6 times negative root 3 is negative 6 root 3. Square root of 2 times 4 is minus 4 root 2. Negative root 2 times negative root 3 is negative root 6. All over. Square of the first term, 16, minus square of the second term, which is 3. Yes.
Positive root 6?
You're right. Positive root 6. My bad. Screwing that one up bad today. You got a new kid throwing me off. I'm kidding.
Yeah, wait.
I'm kidding. Okay. So, can I do anything to my numerator? Root 3, can't simplify that. Root 2, can't simplify that. Root 6, can't simplify that. My numerator is done. I can't do anything to my numerator. There's no simplifying there. My denominator, I can. 16 minus 3 is 13. And that would be my answer. Because I can't, 13, I can't divide all of them by 13. That's it. Sometimes that's what happens with these. Can't go any farther. Next one, what do I multiply by? 2 plus square root of 3. And I got a feeling I'm going to be able to simplify this one down a little bit more. Same thing, FOIL it out. 1 times 2 plus root 3 is 2 plus root 3. Root 3 times 2 plus root 3 is 2 root 3 plus 3. My denominator, square the first term, which is 4, minus square the second term, which is 3. Oh, that's sweet, isn't it? What does my denominator become? 1. Woo! That's nice. This becomes 1. So all I have to do is just combine up any like terms I have in my numerator. 2 plus 3 gives me 5. And then root 3 plus 2 root 3, 3 root 3. And that's it. Sometimes things just go away. Questions? Your turn. Okay, let's go ahead and finish these up. So the first one, it's the easy one, root 3 over root 3. So I get the square root of 15 over 3, over 3. Now, students will often want to reduce this. You can't. The 15 is inside the radical, the 3 is outside of the radical. Outside and inside cannot reduce with each other. They either have to both be outside or both be inside the radical to do any reducing. Okay, so you cannot reduce this one any farther. Next one, I multiply by 7 plus root 2 over 7 plus root 2, which gives me 21 plus 3 root 2 over square the first one, 49, minus the second one, which is second one squared, which is 2. 49 minus 2 is 47. So I have 21 plus 3 root 2 over 47. And that's the final answer on that. Can't do anything to that one. Next one, I multiply by the square root of 3 minus 2. It's still exactly the same, even though the radical's in the front. It's still the same, except for the sign between them. Root 3 minus root 2. Ah, I think it'd be easier. Root 3 minus 2. My first class today, so I'm still waking up. Okay. 5 root 2 times root 3 is 5 root 6. 5 root 2 times 2 is 10 root 2. Root 3 squared is 3. 2 squared is 4. 3 minus 4. 3 minus 4 is negative 1. So when I simplify this, I just change the sign in both terms of my numerator. Minus 5 root 6 plus 10 root 2. And they cannot be combined or simplified, so you're done with that. Questions on that? Okay. Minus 3 minus root 2. Only the sign between them. Minus the root 3 minus root 2. Once again, only the sign between them changes. Nothing else does. FOIL out your numerator. 2 times -3, -6. 2 times negative root 2 is -2 root 2. Root 5 times -3 is -3 root 5. Root 5 times negative root 2 is negative root 10. Square the first term, I get 9, minus the square of the second term, which is 2. So I can't do anything to this other than make my denominator 7. My numerator cannot be changed or simplified in any way. None of those are like terms, cannot be simplified or added together. And then last but not least, once again, just the sign between them. So I get -4 plus root 2, -4 plus root 2. Then I FOIL it out. So -1 times those gives me -4 plus root 2. Sorry, 1 times that. -3 times that is positive 4 root 3 minus root 6. My denominator, square the first term, which is 16, minus square the second term, which is 2. I can't do anything except for simplify the denominator. None of those stuff in the numerator are like terms. Can't combine them up. This becomes 14 in my denominator. In my numerator, I can't reduce. I'm done. Questions? Okay.